This specialized team carries advanced underwater welding equipment, structural assessment tools, and
At 2,400 feet below the surface, the abandoned Japanese battleship Musashi has remained untouched for.
The team begins their descent through 2,000 feet of open water, a 40-minute journey into near-total darkness.
Beyond 800 feet, natural light disappears completely. From here, they rely entirely on artificial illumination. At 2,300 feet, the ocean floor comes into view, and with it, the first signs of their target. There, in the darkness, the abandoned Battleship Musashi. Decades of saltwater submersion have transformed the once mighty vessel into a monument of corrosion and decay. The upper deck structures show catastrophic damage, with all wooden surfaces decomposed and gun emplacements severely compromised. Corrosion has penetrated in some areas to 80% of the original steel thickness, threatening the vessel's structural integrity. Critical hull breaches provide access to the interior, but also represent the greatest structural challenges for the restoration team.
The team identifies 17 major hull breaches, each requiring emergency sealing before any lifting operation can begin.
Interior spaces have been completely flooded for decades, accelerating corrosion from the inside out. Navigating the interior requires extreme caution. Structural collapse is possible at any moment.
The main propulsion system is completely destroyed. Every engine component will require full replacement.
The bridge and all navigation systems are total losses. Complete replacement of all command and control equipment will be necessary.
All interior spaces will require complete reconstruction from the steel frame outward.
Emergency hull sealing begins immediately. Without watertight integrity, lifting the vessel would be catastrophic.
Specialized underwater steel patches and hyperbaric welding equipment allow the team to perform structural repairs at extreme depth.
Each breach requires precise patch placement and complete seal integrity to ensure structural stability during the lift.
Underwater welding at depth requires specialized training. Temperatures exceed 10,000 degrees Fahrenheit at the arc point.
Hydraulic bolts supplement the welded seal, creating a redundant fastening system capable of withstanding enormous pressure during the lift.
With 17 breaches to seal, the team works in continuous rotation, inspection, installation, welding, repeat.
The port side sustained even more severe damage, including the largest single breach encountered, requiring a custom fabricated seal.
The largest breach requires the entire team working in coordination. Any misalignment could compromise the vessel's integrity during lift.
With the critical structural breaches sealed, only minor repairs remain before the vessel can be safely lifted.
12 hours after beginning emergency repairs, above, specialized heavy-lift crane barges move into position. The most dangerous phase of the operation is about to begin. Each lifting chain is rated for 800 tons. Together, they'll support the estimated 2,400-ton weight of the corroded hull. Positioning chains requires threading them beneath the hull at critical load-bearing points to distribute weight evenly.
The center attachment point bears the greatest load and requires precise positioning to maintain vessel balance during ascent.
3 primary chains create a stable 3-point lift system, preventing the hull from rotating or tipping during the 2,400-foot ascent.
Master crane hooks connect all chains to the surface lift system. From this point, over 2,000 tons will be suspended on these connections.
Final safety verification confirms all systems ready. The dive team ascends to safe distance before lift operations begin.
Master crane hooks connect all chains to the surface lift system. From this point, over 2,000 tons will be suspended on these connections.
Surface cranes engage. 2,400 tons of dead weight begins to transfer from ocean floor to lifting system. The abandoned Japanese battleship Musashi lifts clear of the ocean floor for the first time in decades, the most critical moment of the entire operation. The ascent takes 4 hours, rising at 10 feet per minute to prevent structural stress from rapid pressure changes.
The abandoned Japanese battleship Musashi returns to the air after decades in darkness. Emergency hull patches hold perfectly, not a single leak as the hull clears the surface.
Complete clearance achieved. The entire 860-foot hull suspended above water, chains holding strong.
Lowering operations take 3 hours. The same careful precision that brought it to the surface now places it safely on the transport barge.
Industrial securing systems anchor the hull to the barge. The cargo must remain absolutely stable during ocean transit. 3 ocean-going tugs will tow the convoy 400 nautical miles to specialized dry dock facilities equipped for restoration work.
At 4 knots, the 400-mile journey will take 4 days. Slow, careful progress protecting the fragile cargo. Four days after leaving the salvage site, the convoy approaches the restoration facility.
The dry dock gates open. Inside, precisely positioned support blocks will hold the vessel during restoration operations.
Entering the dry dock requires precision navigation, inches of clearance on each side, as the 400-foot wide barge passes through.
Gates sealed, the basin is isolated, ready for controlled draining operations.
Pumps remove 50 million gallons of seawater from the basin, a process taking 18 hours.
As water drains away, the full extent of corrosion damage becomes visible in daylight for the first time.
With drainage complete, restoration teams access the vessel for the first time in controlled conditions. Comprehensive assessment begins immediately.
A 40-person engineering team begins comprehensive structural assessment. Every system, every compartment.
Ultrasonic testing reveals 60% of the original hull plating has corroded beyond safe structural limits and must be replaced.
Engine room assessment confirms complete propulsion system failure, new engines, generators, and all mechanical systems required.
Bridge evaluation shows total loss. Modern navigation, communication, and control systems will be installed during reconstruction.
Final assessment confirms the magnitude of work ahead. 60% hull replacement, complete mechanical systems, over 400 tons of corroded steel will be cut away and replaced.
Oxyacetylene torches cut through decades of rust and corrosion, removing damaged plates to expose structural frames beneath. All 3 main gun turrets are removed. Each turret assembly weighs 60 tons and is corroded beyond repair.
Interior demolition removes all damaged compartments, creating a clean slate for complete reconstruction of crew spaces.
After 6 weeks of demolition, 400 tons of damaged material removed, the vessel reduced to sound structural skeleton ready for reconstruction.
Over 400 new steel sections are precision fabricated to exact specifications.
Installation begins with careful positioning. Each plate must align perfectly with mounting points before welding can commence.
Certified marine welders create permanent structural bonds, each weld inspected with X-ray equipment to ensure perfect integrity. Over 3 months, 300 individual steel plates are installed. 60% of the hull completely reconstructed with new material.
New deck construction uses reinforced design, stronger and more corrosion-resistant than the original 1940s engineering.
Industrial sandblasting removes every trace of rust from original sections, exposing clean steel ready for protective coating systems.
Bridge reconstruction maintains the original profile while incorporating modern structural improvements and safety features.
Corrosion-resistant primer creates protective barrier, the first of 5 coating layers that will protect the steel for decades.
Final paint system creates authentic appearance while providing superior weather protection, exactly matching the original historical color scheme.
Modern marine diesel turbines replace the destroyed steam engines, providing reliable power while maintaining historical appearance from exterior.
Complete electrical, hydraulic, and mechanical systems installation. Modern reliability combined with historical authenticity.
Modern navigation and communication systems are integrated into the restored bridge.
Complete interior reconstruction creates modern crew spaces while respecting the historical layout and design.
Final detailing ensures every system, every surface, every component meets exacting standards. Restoration perfection.
First engine start. After 18 months of reconstruction, the abandoned Japanese battleship Musashi has power for the first time in decades.
All systems activate successfully. Navigation, communications, propulsion, all functioning perfectly.
Dry dock flooding begins. The moment of truth, as the restored vessel will float for the first time.
Water rises for 6 hours, gradually lifting the 2,400-ton vessel off support blocks.
With all systems verified, the restored vessel prepares for sea trials, the ultimate test of the restoration work. Sea trials demonstrate flawless performance. Engines, navigation, all systems operating perfectly. Full-speed trials confirm all performance parameters met. The restoration has created a fully operational vessel. From the ocean floor to operational vessel, an 18-month journey.
Every detail perfected, from structural welds to cosmetic finishes, a complete restoration to operational condition.
From 2,400 feet underwater through 18 months of intensive work, 400 tons of new steel. Initial assessment reveals extensive structural degradation across the entire hull, with critical breaches below the waterline.
A fully operational vessel, combining modern technology with historical authenticity, ready for continued service. A legend recovered, restored, and returned to the sea. The abandoned Japanese battleship Musashi lives again. Rust falls, steel rises. This is Dead Metal. Subscribe now and watch machines live again.